Okay, when last we met, we were looking at improper integrals. And we were looking at improper integrals of the form, maybe something like this, the integral from 0 to infinity of 1 over x plus 1 dx. So improper integrals can happen when you have an infinity here or a negative infinity. But those are not the only type of improper integrals. For example, this would also be an improper integral. The integral from negative 1 to 2 of 1 over x plus 1 dx. What makes that integral improper? Any ideas? If I plug negative 1 in, I get a discontinuity right there. In fact, I get a vertical asymptote. So that's the other way that improper integrals can happen. Improper integrals can happen when there's a vertical asymptote within your given domain. And here we definitely see that. We would have 0 on bottom. So what we're going to do in this situation, we're going to take the limit as a goes to negative 1 from the right of the integral from a to 2 of 1 over x plus 1 dx. Why do I have the limit as a goes to negative 1 from the right? Why don't I just have the limit as a goes to negative 1?
You just take one from both sides to see where the asymptote comes.
No, not really.
We're looking at the area to the right of negative 1.
My interval goes from negative 1 to 2, so I'm only looking at numbers to the right of negative 1. I don't care about numbers to the left of negative 1 because my interval starts at negative 1 and ends at 2. Okay? This is the limit as a goes to negative 1 from the right. What's the antiderivative of 1 over x plus 1?
Natural log of x plus 1.
Natural log, absolute value of x plus 1, evaluate at a and 2. So this is the limit as a goes to negative 1 from the right, ln 3 minus ln of a plus 1. What happens when a gets close to negative 1? What is bigger than negative 1? This gets close to ln of 0, and ln of 0 is undefined, but what's happening when you're close to 0? What's ln doing when you're getting close to 0? It is increasing, that's true, because ln is always increasing. But more importantly, what are the y values getting close to? Not 0. Negative infinity degree. Remember your ln graph? Your ln graph looks like this. So when your x values are getting close to 0, your y values are getting close to negative infinity. So we would say that integral is divergent. It does not get close to a number, it's getting close to infinity. So our answer there would be it's a divergent improper integral. Questions on that? All right, how about, change this one ever so slightly. What about the integral from negative 1 to 2 of 1 over the square root of x plus 1 dx? That's still an improper integral. Why is that still an improper integral? When you try to plug in negative 1, you still get 0 on bottom. You still have a vertical asymptote issue there. So we would do exactly the same thing. This is a limit as a goes to negative 1 from the right of the integral from a to 2 of 1 over the square root of x plus 1 dx. That's the limit as a goes to negative 1 from the right of, what's the antiderivative of 1 over the square root of x plus 1? Think of this as being that 1 over the square root of 1 is x plus 1 to the negative 1/2. You're going to add 1 to your power. That's going to give you a 1/2. You're going to divide by your new power. That's going to give you a 2, isn't it? Divide by 1/2. Technically, you're doing a u substitution. U is x plus 1, but du is dx. It works out perfectly. So this is 2 square root of x plus 1, evaluated at a and 2. When I plug in 2, I get 2 times the square root of 3 minus, what happens when I plug in a and then I take the limit as a goes to -1 from the right? Well, -1 plus 1 is 0. Square root of 0 is 0. So there's an improper integral which converges. Sometimes improper integrals converge, sometimes they diverge. Depends on the integrals. Questions on that? How about the integral from -3 to 3 of 1 over x dx? What would you do? U sub. U is?
That's just natural log, isn't it?
The integral of 1 over x is natural log x? Yeah, I think so.
Yeah.
You try to break up the interval.
Why?
Because at 0, you would have an asymptote.
Ah, very good. This is an improper integral, but it's kind of hidden. This is an easy one where I'll see a lot of people do this. They'll write this is ln x, evaluate at -3 and 3. So that's ln 3 minus ln 3, which is 0. Everything looks proper, everything looks great, but that's the wrong answer. The problem is 0 falls in between -3 and 3, and what happens at 0? There's a vertical asymptote.
So you rewrite it as 2 integrals?
So you have to rewrite it as 2 integrals. That's correct. So that's very, very tempting. And it's very easy to make that mistake. It's very easy to forget that there's a vertical asymptote in between. Maybe not so easy with this one, but easier to forget with other ones. And I'll give you one in a minute here where it would be easy to forget. So what you really have to do with this problem is you have to split it from -3 to 0 plus the integral from 0 to 3. You have to split it where the discontinuity occurs, split it where the vertical asymptote occurs. Okay? And then what has to happen is this integral needs to converge and that integral needs to converge. If either one of these diverge, then the whole thing diverges. If they both converge, then they converge to the common summation. All right, so what are we going to do with this one? This first one, we're going to write it as the limit as b goes to 0. Do I want b going to 0 from the left or from the right? From the left of the integral from -3 to b of 1 over x dx. Plus this one, I would have the limit as a goes to 0. How come I use a for this one and I use b for that one? Because a goes on bottom and b goes on top. And this one would be a would go from 0, but it would be from the right of a to 3 of 1 over x dx. So I have to split it into 2 different integrals, which forces me to have 2 different limits. Okay, limit. B goes to 0 from the left. What's the integral of 1 over x? ln x. And then I'm going to have my numbers b and -3. Plus, this one's going to be limit as a goes to 0 from the right of ln x. And I'll have my a to 3. Okay, well, I plug in b, and then I let b get close to 0. What happens when I plug in b into my ln x, and then b gets close to 0? It goes to negative infinity. So what can you tell me about this first integral? It's divergent. So this one happens to be divergent. By the exact same argument, it turns out that that one is divergent, and that's usually going to happen. If one of them's divergent, they're usually both going to be divergent. If they're not both divergent, it doesn't matter. As soon as you say one of them is divergent, the entire answer is divergent. You're done. So once you get one of them to be divergent, you can actually stop. But in most cases, most of them will turn out to be divergent. So our answer for that problem would simply be divergent.
So divergent means that
Infinity or negative infinity. Yeah. What's that? It could be either one. It could be plus infinity or minus infinity. In this case, it's minus infinity, because when b gets close to 0, I've got ln b minus ln 3. So this one I'm getting a negative infinity. Oop. Close enough. Divergent.
We don't have to write down whether it's positive or negative.
No, all you got to tell me is divergent. You don't have to tell me if it's plus or minus. I don't care.
All right.
Once it's one of them, you're done. Divergent.
you plug in the notice and you write it that.
I'm not sure what they want in WebAssign. I'm sure they'll tell you if it's divergent, type something. Maybe just a capital D. I don't know what they'll have. But I'm sure they'll tell you in the directions. Other questions? These improper integrals can be hard to find, or easy to miss, I mean. And I've done this on a test before, believe it or not. The integral from 0 to pi of secant x dx. In fact, I think that used to be one of our competency questions. Back in chapter 5, that was one of our competency questions. And a whole bunch of math teachers looked at this, and a whole bunch of us made the same mistake. What's wrong with that? There's an asymptote in between. Where's the asymptote? Not 1. At pi over 2, because pi over 2 is where cosine is 0. So what we expected, and it's kind of funny because somebody wrote up the competency questions and even wrote up an answer key. And they wrote this. And you plug in the numbers, you get ln secant of pi plus tangent of pi, and you get an answer. Secant of 0, secant of tangent. These are all nice numbers. You get an answer. It's not the right answer, though. Why not? There's a vertical asymptote in between. That integral actually diverges. But this used to be one of our competency test questions, and a whole bunch of us saw it, read it, and forgot that that's an improper integral. So that's what I mean when I say it's easy to miss these. It's easy to see this, use your fundamental theorem of calculus, plug your numbers in and think you've done it great, and you get the wrong answer.
So would it be a good idea to graph it out before you do it?
Always a good idea to graph it out before you do it. Yeah. Graph the function and make sure there's no vertical asymptotes. I mean, most of the time you don't have to worry about it. I mean, if I were to give you that, sine x doesn't have any vertical asymptotes, so there's no way you can have an improper integral there. Nothing to worry about. It's where you have functions where you can have vertical asymptotes where you need to think about it. And make sure you don't have any vertical asymptotes within your domain. Okay? So don't fall into the trap. This one's pretty easy to see. Everybody usually remembers you can't plug 0 in. People don't usually mess up this one. But this one, easy to, when you have trig functions involved, it's easy to forget to look for those vertical asymptotes. Questions on improper integrals?